Hey guys, Jake Go Back Knives. Just wanted to go over something today for guys out there that are just starting to make folders and stuff like that. I had a discussion with some of the boys on the board, like Brian Felter and Mick Strider, and I believe Bob Drazula got on there, and Tom Mayo and all that stuff, and we're just kind of going over a few things about lock geometry. And a lot of those guys don't run internal stop pin, they run external, so it would be up here. Some of my original designs, like my first A10s, probably the first 5 or 6 of them had an external stop pin. Nothing wrong with that design. I just prefer an internal stop pin because it's easier to do. Actually, Dave at Great Lakes Waterjet turned me onto that and helped me get the initial setup here. So I guess in a way just want to give back. A few things I've discovered in the last couple of years now, I guess, of making folders, and I guess this is probably, I don't know, I've made a couple hundred of them, maybe a little less than that now. But some of the designs, and I figured I'd go over with you guys in case anybody missed the thread about lock geometry. Your biggest thing that you're wanting to go over is, like the way Bob Drazula says it, he wants an equilateral triangle, so an equal-sided triangle. So from the center line of the pivot here to the center of the stop pin to the very bottom of the lock face, because the bottom portion of the lock face is the only portion that should be touching the lock tang. So you have a triangle if you draw straight lines between these, right there. Bob says you want an equilateral triangle. Brian says that it doesn't matter as long as you have the top of the lock bar and the lock face pushed as far forward and down below the pivot as possible, which makes sense because the further in the lock face you have, the more force is directed straight back on the lock bar compared to, say, pushing it up. I'm as close in as I can because of these bearings that I use. They're 1/2 inch outside diameter. I can maybe push that in another 20 thousandths, and I have changed my designs a bit, but what I did to compensate for the fact that my lock bar has to be that far back is on my new designs, the lock bar comes down this way instead of being where it is now, so I pushed it a little further forward. That'll help a little bit. Honestly, I doubt anybody will really notice anything, but I have been trying to make these as best as seemingly possible, so anytime I get new information I try to apply it. One thing I wanted to address, and Brian made a good point of this, and he drew some pictures, and I suggest you guys check out the thread on the USN about it. If you take a straight line and draw it to the bottom between the center line of the pivot to the bottom of the lock face, if you draw a straight line like that, okay, now 90 degrees off of this point here, right here, so get another piece of something straight, so like that. This right here is the direction your lock force is going to be pushing, so it's going to want to push the lock up a bit, okay, 90 degrees from that point, so from here to there. If you were further back, that line would be pushing up further because it would rotate that angle. So that's important. You want the lock force as much as possible within your design parameter to push straight back on the lock bar. That'll prevent lock slippage. And it'll also prevent, it's not really lock rock, but what it is that you have so much force on the tip when pushing down on the edge of the blade, or the top of the blade, that it's wanting to bend or flex the titanium, and you'll actually flex the materials because you have more leverage. So push forward as far as you can. One thing I'm discovering too, internal stop pin, and this is something me and Brian kind of went back and forth on, and I'm not sure if we ever really agreed or just agreed to disagree, but okay. So, and my camera sucks, so I'm sorry. I wish I could show this to you guys a little better. But if you look here where my stop pin hits the frame in the open position, there's a gap back here on the lock face, and it touches the lock, touches here, only here, for the first 60 to 100 thousandths or so. Now this stop pin, it's hard to explain, but let me put it this way. I want the stop pin to touch the uppermost portion of this arc, okay? Because the way this is designed, if you have any bit of play in your pivot through wear or through the fact maybe it's machined just slightly loose tolerances, you'll be able to wiggle the blade just a touch. And what you want to do is get the stop pin to touch the very uppermost portion, because what will happen is now the lock tang is going to have a little more travel up and down wise to push against and cam against the pivot. That'll make it much more difficult to be able to flex the lock and also feel any play in the blade. So before, you notice, I doubt you can freaking see it. I need a better macro version for video on this. But there's just a tiny little gap at the very bottom of the stop pin, and it's touching at the uppermost portion here. Touches here. There's a gap of maybe 1/2 thousandths right down here. What that's doing is it's applying more pressure to the top. When this lock is touching and pushing it this way, it allows it to cam and take up any slack that'll develop over time when the pivot wears, because the pivot is softer than the blade steel. Bound to happen. So what I'm trying to do is build a design that compensates for wear a little better than what you normally get. I have changed my designs where the stop pin actually is up here, so it allows me a better camming action in there to account for wear. I may be completely off center on this. I'm sure somebody will come in and comment if they've got some questions or if they've got a better idea of it. Geometry was not my strong suit, but I pick up things here and there and try to apply the best of everything that I can find information on. So like I said, just to recap, you want your triangle, which is good. I say the bigger the triangle, the better, because you have stronger, it's larger. You'll have less leverage on the tip of the blade if you have a larger triangle area here than if you have them very small. If this stop pin was up here and your lock face was up here, you'd have a very small portion of strength from pushing down on the tip of the blade, and it would want to either break the stop pin or the lock face or whatever. The larger, the further away you can get them within reason, will allow you less leverage on the tip of the blade. So in theory, when it flips open, it'll actually be a stronger design so that it won't want to deform or bend or break or anything like that. I could be wrong, so tell me if I am. I always want to know if I'm wrong, that way I can fix things. But triangle, lock face needs to be as far forward and down below the pivot center line as possible. In a perfect world, the lock face would be directly below the pivot, and pushing, that would give you the strength to push, or all the tension or all the pressure would be pushing straight back on the lock bar. So, alright guys, sorry for the rambling kind of post. I was just thinking about this, and I knew a couple of guys were asking me questions on YouTube, so I thought I'd put up a video and show you guys. Hopefully that makes sense. If not, just let me know. I'll try to edit this video and put in some pictures of my CAD files so that you can kind of see the rotating version of it. So, alright guys, have a good one. Okay, so part 2 here. I stepped over to the computer and pulled up my A8 CAD file. And the way this one is working is I've rotated the stop pin track, so I have a larger triangle here. So let me show you that. So from center point to center point to center point and back, what that's given me is a lot wider triangle here than when the stop pin here was down here. So it gives me a little more room to work it. What I was talking about earlier with the lock angle, and I'll show you how to figure this out when you're building your own folder. So I go a straight line from the center of the pivot down to the end of the lock face where it touches, and then I want to do a 90 degree. So I'll pull this out to 90 degrees here in just a second. Find my angle here. Come on. Almost there. Okay, 90 degrees. Okay, so the lock force, since this is 90 degrees, the lock force is going to be generated way further back here, about midpoint of the lock bar. Let's see if you can see that a little better. There you go. That's better than when my lock face was moved back here. It was 90 degrees to the lock bar itself. Didn't quite work out as well. And then also I've straightened my lock bar a touch, and that'll help also. So you're going to get a lot stronger lock because the pressure is being pushed back this way instead of up here. So let me delete this. Okay, one other thing that I was working on here was what I mentioned earlier, the rotation of the stop pin. What that's going to give me is if I have a hole around my stop pin in the blade, maybe it wears, or the stop pin wears down a thou or so, and it's got a little bit of wiggle. The nice part about having it with a triangle setup like this is that when I push the lock bar here, it forces the blade into the stop pin here. Now when I cut this section of the stop pin slot, or the track, I'm going to make it so that the stop pin touches this corner of the side of the blade, not this corner. So what that'll do is that'll allow me some camming action there. The stop pin will touch here. I'll try to get as arced and a good arced portion so that it touches in more than just one point, but it'll be touching more towards the inside. And if you get some wear in this pivot, it'll cam basically against it, and it'll allow to have a little more wear before you'll notice it in the blade. So you'll, like I said again, pressure from the lock bar pushes this way against the stop pin presses against the inside portion of the stop pin track and allows a little bit of camming. Not much, but it'll take up a thou or two maybe around the stop pin hole when it wears, or if the pivot wears. So hopefully that helps you guys if you're doing some designs and stuff. If you have any questions, give me a holler. I'm not the foremost expert on this, but from what I understand, this should work pretty well. So thanks for watching the video. Thanks.